Do you want to learn how to make a hybrid robot and control it wirelessly? Then you should watch this video from start to the very end. So guys, this is the robot that we're gonna be working on. It's a hybrid robot. Over here a solar panel will be installed and its angle can be controlled by rotating this plate, and then we can tight this. Okay, and this is the receiver circuit, and these two relays will be used to control the charge to the battery from the wind turbine and from the solar panel. And these are the two H bridges which are used for the motors controlling. There's only one motor installed. So in this project we are using only one motor, so the movement of the robot will be in forward direction and reverse direction only. So if we're gonna use two motors, then one motor is connected over here and the other motor will be connected over here. So currently we are using only one H bridge. And this is the transmitter circuit. So this button will be used for the forward movement and this one for the reverse movement, and this one will be used for charging from the wind turbine. This button will be used for the on and off, and this one will be used to control the charge from the wind turbine. So if we activate this button, then the battery will be charged from the wind turbine, and if we turn on this one, battery will be charged from the solar panel, and if we turn on both the buttons, then the battery will be charged from both sources. And over here you can see that all the wires are connected, so the Arduino Uno and all these relay boards will be powered up from a battery, from a 12-volt battery. So we will completely discuss, and I will show you the circuit diagram and the soldering and then the practical testing. So watch this tutorial from start to the very end and don't skip the discussions. So let's start working on this project. So the things we'll be needing for this project are push buttons. As you can see, these are simple push buttons. And in a couple of minutes I will start the soldering. Okay, so this is the remote control I'll be using for controlling the robot. This button will be used for the forward movement, and this one for the right, and this one for the left, and this one for the stop, and this one for the solar panel activation, and this one for the wind turbine activation, and obviously this will be used for the off. We will also be needing an Arduino Uno and a radio transmitter, which is for 33 megahertz, and this is the receiver. So first we will make the remote controller, and then after that we will be making the receiver circuit. So let's start the soldering. So before we start the soldering, first let me show you the basic circuit diagram of the transmitter. Here I'm using 1, 2, 3, 4, 5, 6, 7, 8, total of 8 buttons. Now one button will be used for the straight movement of the robot, and that push button is connected with pin 2 of the Arduino, and S3 is connected with the pin 3, where it will be used for the right direction, and this one is for the left, and it is connected with pin number 4. And this button is connected with pin 5 of the Arduino and will be used for stopping the robot. And this button is connected with pin 6 of the Arduino and it will be used for the charging from the solar panel. And S5 is connected with pin 8 of the Arduino and it will be used for start charging from the wind turbine. And similarly, S9 push button is connected with pin 7 of the Arduino and it will be used for stop charging from the solar panel. And similarly, the last push button is connected with pin 9 of the Arduino and it will be used for stop the charging from the wind turbine. And as you can see, one side of all the push buttons are connected with ground, with the Arduino ground. So that's the basic circuit diagram of all the buttons. And the transmitter data pin is connected with pin 12 of the Arduino, and the ground pin of the RF transmitter is connected with the ground of the Arduino, and similarly the VCC is connected with plus 5 volt of the Arduino. So this is the basic circuit diagram that we will be using for the remote controller. So now let's start the soldering. Okay, now that all the buttons are soldered, and now we will start the connections. So now as you can see, one side of all the buttons are connected with ground, so let's confirm that the DMM is already set on the continuity. So just connect one here. This is the ground wire, and as you can see, so one side of all the buttons are connected with the ground. And now let's solder the other wires which will be connected with the Arduino. So let's start the soldering. Okay, now the remaining wires are soldered, and let's confirm. This is the ground wire and connecting with this one, and you can hear the beep sound. So the button is working. Let's check this one. working. Yeah, also working. And now let's check this one. I've already checked all the wirings and it's working just fine. So we are done with the wiring, and now we will start the interfacing. But let's first connect the radio transmitter. We will need 3 wires. Connect VCC. This is the VCC. The green one is the ground, and the yellow one is the data. Now we will connect these 2 modules with the Arduino board, and once I'm done with the interfacing, I'll be back. So now, as you can see, all the wires are connected with the Arduino, and these wires are connected as per the programming. So the button which is connected with 2 for the straight movement, and this is this button, this one, and this is for the straight, and for the right, this one is for the right, which is connected with pin 3, and for the left, which is connected with pin 4, this is for the left, and this is for the stop, which is connected with pin number 5. And to start charging from the solar panel, so this button is connected with pin number 6, and this button is connected with pin number 7 to stop charging from the solar. And to start charging from the wind turbine is connected with pin number, which is this one, and it is connected with pin number 8, and this one is connected with pin number 9. And now let's check the receiver code. I've already uploaded this program in the microcontroller, and now let's open the receiver code. Okay, so this is the receiver module. It has 3 pins. Well, actually it has total of 4 pins. The 2 pins are the data pins, so I've connected one, and the other one is the 5 volt, and the gray one is the ground, which these are clearly labeled on the receiver over here. This is the VCC, and this is the ground, and the middle one is the data. So here you can see the receiver pin is connected, the data pin is connected with pin 11, and as we are going to control a robot, so for that we'll be needing 2 H bridges. This is the left motor wire 1, which is connected with pin number 7, left motor 2 wire 2, which is connected with pin number 8, and the right motor wire 1 is connected with pin number 2, and the right motor wire 2 is connected with 3. So for now we will just only check the wireless communication. So right now I'm connecting the transmitter 12 volts, and I'm also connecting the receiver. Okay, and now let me open the terminal. Okay, so for the straight movement, as you can see, it's H, and this one is for the right movement, which is J for the right, and L for the left, and Z for the stop. And this one is charging from the solar started, and this one is charging from the solar stopped, charging from the wind turbine started, and charging from the wind turbine stopped. So this is just the basic working operation, that how the wireless communication is done. As you can see over here, the receiver is connected, and it's already connected with the computer. Okay, so now we will start the programming, and I will explain step by step that how the transmitter and receiver are actually working and sending commands to control a robot. So now let's start the programming. So this is the remote control programming. So before you start the programming, make sure that you download the virtual wire library, and after downloading this, just simply copy and paste this in documents, and then Arduino libraries, and you paste it over here. So as you can see, I have already downloaded it, and this is virtual wire. So then after that, just ignore these two instructions, this one and the transmit EN pin. So the constant integer transmit pin is equal to 12. The pin 12 of the Arduino is connected with the data pin of the transmitter, and these are the buttons. These are the different push buttons. 1 2 3 4 5 6 7 8. We have total of 8 push buttons, and these are the Arduino pins with which all these buttons are connected. So the pin number 2 is used for the straight movement of the robot, and pin number 3 will be used for the right movement of the robot, and pin number 4, 5, 6, 7 will be used for the left stop and for the charging, and 7 number is used to stop charging from the solar, and pin number 8 to start charging from the wind turbine, and pin number 9 will be used to stop charging from the wind turbine. So as we are going to make a hybrid robot, so that's why we will be using the solar panel and the wind turbine. Each and every Arduino program has at least 2 functions. The one is the white setup and the other one is the white loop. The white setup function executes only one time, and as you can see, the white means that this function is not returning any value, and as you can see, the parentheses are empty, so this function is not taking any arguments as inputs. VW, which is for the virtual wire, set TX pin, which sets the transmit pin, which is the transmit pin, and we know that a transmit pin is pin number 12. So we will send all the commands using pin number 12, and as we know that the push buttons are the input devices, so that's why these are the inputs, and VW virtual wire is 2000, and that's the bits per second. Byte count is equal to 1. We are not using that, but okay. And while loop, so the while loop runs infinite times, and these are the different commands which we will be sending when any of the push button is pressed. So when we press a button which is will be used for the straight, so when we press that button, it will send H to the receiver, and for the right it will send J to the receiver. And as you can see, that this is MSG, this is MSG1, MSG2, and these are arrays, MSG3, MSG8. So if you need more characters, you can just go on like that. Character MSG13 7 is equal to, you can use any other character. Okay, you can also use English letters, the smaller or the capital or the numbers. So now these are the conditions, and all the conditions are exactly the same, only the array names are different. So if digital read button is equal to 0, so this condition means that check if the button is pressed. Is equal to 0 means that check if the button is pressed. Then what to do? Send MSG. And what is MSG? MSG has H, so when that button is pressed, the H will be sent to the receiver. And then VW wait TX, wait until the whole message is gone, and then delay, wait for 1 second, and then it's ready for the next. If digital read button 1, now what is button 1? Button 1 is connected with 3 number, with pin 3 of the Arduino. So when button 1 is equal to 0, then send the MSG1. What is MSG1? MSG1 is J, which is for the right movement. So it will send J to the receiver. and similarly all the other conditions are exactly the same, only the arrays names are different. So this is MSG2, this is MSG8, and this is MSG9, MSG10, and MSG11 and 12, and that's it. Just a simple program. So this is the receiver circuit diagram. The receiver circuit consists of 6 relays. This is relay number 1, 2, 3, 4, 5 and 6. These 2 relays are used for charging the battery from solar panel and wind turbine. Watch my previous tutorials on relay driver circuit design calculations for the best understanding. So the charge from the solar panel to the battery is controlled with the help of this relay, which is connected with pin number 5, and the charge from the wind turbine to the battery is controlled with the help of this relay, which is connected with pin number 7. Okay, so these 2 relays are used for the charge controlling. Okay, now this is the edge bridge number 1 and this is edge bridge number 2. I also have a very detailed video tutorial on the edge bridge designing and programming, in which I also covered the Proteus simulation, so watch that video. So this is the external supply, and this one also. As you can see, the positive wire from the external supply is connected with the normally open of the relay, and similarly this one, and the normally closed pins are connected with the ground of the external battery. Similarly, the one side of the relay coil is connected with plus 12 volts and the other side is connected with 2N222 NPN transistor, and this one is connected with pin number 7 and the other relay is connected with pin number 8, and similarly this one is connected with pin number 2 and pin number 3. So these are all the exact connections, and this is the 433 megahertz receiver, and the data pin is connected with pin 11 of the Arduino, and the 5 volt of the radio receiver is connected with plus 5 volt of the Arduino. So this is just basic circuit diagram. For the detailed discussions and programming and designing, please watch my previous tutorials. So this is the same edge bridge which I explained in the circuit diagram. I prepared this Proteus simulation just to show you how an edge bridge actually works. We know that edge bridges are used for controlling the direction of the motors. So these are the 2 relays. This is relay number 1. These are the 2 coil pins of the relay, and this is the normally open, this is the normally closed, and this one is the common pin of the relay. And similarly, these 2 are the coil pins of the relay. This is the common pin, and this is the normally open, and this is the normally closed. These are of the type ESP32, which stands for the single pole double throw, and this is RL relay number 1 and this is relay number 2. So the one side of the relay coil is connected with plus 12 volt, and over here also the one side of the relay coil is connected with 12 volt, and the other side of the relay coil is connected with the ground through 2N222 NPN transistor. Why we are using 2N222 NPN transistor? Why we are not using any other transistor? So how we calculated that and how we know that we have to use this particular NPN transistor? So watch my previous tutorial on the relay circuit design calculations, and that I explained. So now how it works actually, let's play and see. Now you can see the motor is off, it's not running. Why? Because there is no change in polarity. As you can see, the common pins of both relays are connected with the motor. So this side is also connected with the motor, and this side is also connected with the motor. And as you can see, this side is also connected with plus 12 volts, and this side is also connected with plus 12 volts. So as there is no change in polarity, so the motor is stopped. So if I press A on the keyboard, so now as you can see, now
Now this side has shifted. Now this is connected with the ground, and this is connected with the plus 12 volts, so the motor is running in this direction. So what happens when I press B? Now as you can see, now this side is connected with ground, and now this side is connected with plus 12 volts, so that's why it's running in another direction. And if I press S on the keyboard, so it stops. So the purpose of this simulation is just to show you that how an edge bridge actually works. While in the radio frequency control robot, we'll be controlling the edge bridge with the help of the radio transmitter, which I will show you in a few minutes. So now let's discuss the programming. Again, H include virtual wire.h, and then after that the LED pin is 13, and integer write motor wire 1 is 2, which I already explained it. And these are the two edge bridges, and each edge bridge has two wires, and each wire is controlling one relay. So those two relays are used to, so we have total of 4 relays. The one relay is connected with pin 2, another one pin 3, 7 and 8. So the 4 relays are used to control 2 motors, and each motor has 2 wires. So the right motor wire 1, the right motor wire 2, the left motor wire 1, and the left motor wire 2. And 2 relays are connected with pin number 5 and 6, and these 2 relays will be used for charging a battery from the solar panel and from the wind turbine. Okay, so these are 2 flakes. Watch my previous tutorials on flakes, how to use flakes in Arduino for the best understanding. That's a very detailed tutorial. Then again, the wire setup, same instructions. Keep all the motors low, keep charging low by default, and then the wide loop and some instructions. VW maximum message length, which is for the message length, and VW maximum message length, and then that is FVW, which is the virtual wire get message buffer and buffer length, and integer I, so which reads the entire buffer, and character C is equal to buffer I. So anything it receives will be stored in C. So anything which is sent from the transmitter will be stored in C, and if C is equal to C, and we know that the Z is used for stopping all the motors. As you can see, all the motors are low, and J is for the right movement. So as you can see, only one motor is running one direction and all the other wires are low. And likewise for the H, as it is for the straight movement, so one wire for one motor is high and one wire of the other motor is high, so both the motors are running the same direction. And for the left, which is L, as you can see over here, this motor is now running one direction and the other motor is off. And now this is the flake. S flake is equal to 0, and FC is equal to S. So check if there is a character which is coming from the transmitter. If it is S and the S flag is 0, then what to do? Turn on the charging from the solar panel and change the flake status, and print on the computer screen which is charging from the solar started. And similarly, this is for stopping the charging, which is T, and this is W for the start charging from the wind turbine, and this is for X is for stop charging from the wind turbine. So that's it, a very simple program. So this is the final receiver circuit. These are the two edge bridges, edge bridge number 1 and edge bridge number 2, and these are the 2 wires which will be connected with the battery, external battery. And it doesn't matter which wire you connect with which battery terminal. So these 4 wires will be connected with the external battery, and over here we can connect the motor. So motor number 1 will be connected over here, and the motor number 2 will be connected over here. So these are the 2 relays, and these are the 2 relays, and
This relay will be used for the solar panel, and this one will be used for the wind turbine, and I'm not using this relay. So I'm using 6 relays, and all the connections are as per the circuit diagram. This is the receiver module, this is the 12-volt adapter, and another 12-volt adapter is over here. So this is the receiver, and this is a transmitter which we designed yesterday. This is the remote controller, this is the transmitter. So now let's check this. When I press this one, so as you can see there is no connection. This is the radio receiver, and this is the transmitter. So as you can see over here, stop. So for the demonstration purposes, I have connected the DMM over here, which is set on the continuity, just to show you how the charge from the solar panel will be controlled with the help of this relay. So when I press this one, which I told you in the previous tutorial that this will be used for the charge controlling from the solar panel. So when I press this one, as you can see, and this one is for the forward, this one is for the stop, forward, stop. This one is for the right, this one is for the left. So this is for the forward, stop, solar panel, and wind turbine. On, off, on, off. So now as you can see, the circuit is powered up, and a digital meter is connected with the output of the turbine. So as you can see, currently there is no voltage on the meter because the charging from the wind turbine is off. So let me turn that on. Okay, and now you can see, and now I can turn it off, and now you can see it's running no voltage. And now let me show you the forward and the reverse movement. Moving in forward, stop, and that is on the other side. So the speed is slow just because that the motor alignment is not okay, so later we will fix this. And this button can be used for controlling the charge from the solar, and it's working. You can hear the tick sound. So everything is fine, working fine, and it's completely wireless.